All right, thank you so much for joining us today. And in this video, we have 8 set of questions that we are going to go through together. So let's start. We have this question here, and then we want to find all the critical values in this given interval, right? So we have the domain here. So making sure that our critical value is inside this domain. So how do you find a critical value? The first thing that we need to do is we need to differentiate f of x. So let's try and differentiate f of x. So this is our f of x right here. So when I do the differentiation, I'm going to have 3x squared minus 6x minus 9, right? So now let's do something like factorization here because this is quadratic. So I'm going to have 3 out x squared minus 2x minus 3. So now I want to find two numbers that when I multiply I'll get 3, but when I add or subtract I'm going to get this. So basically we know that factors of 3 are 1 and 3. So 1 and 3 is going to work for us here. So we are going to have 3x squared minus x minus, no, 1 should be plus, so this one should be plus, then we have this to be minus 3x minus x, so that 1 times minus 3 is this, and then x, this is going to give us this here. So with this one here, we are going to have 3 open bracket x out x plus 1. Then with this one, we can factor minus 3 out, and we are going to have minus 3 out x plus 1. So these are the factors that we are going to get. So we can have something like 3x, and then this and this are common. So we are going to have x plus 1. And then when I take the common term out, it will be left with x minus 3. So you are going to multiply it by x minus 3. So now since we are looking for the critical values, now we can see that critical values are the values that make sure that this is equal to 0. So now this is not hard for us to see that when s is equal to minus 1, the function will be 0. And when s is equal to 3, the function too will be 0. But the question is, we want to find the critical point that is inside the domain. So if you are not in the domain, we just drop you out. So minus 1 is not in the domain, but x is equal to 3 is in the domain. So here we are going to conclude that therefore the critical point or the critical value is 3, which is x is equal to 3, which is in the domain. So in the domain 0 and 4. Right. So that would be the first thing that we need to do. So find the derivative, do the factorization, look for x values. Here, when you are doing the factorization, you should be very careful, because if you get this one wrong, it means that this one is going to be wrong, and what you are coming to do here probably is going to be wrong. Right. So now we want to find the absolute max and absolute minimum. So what do we need to do? We just need to construct our table nicely. So let's do that. Good. So we have our x and we have our f of x. So what we need to do is we need to use the critical point and then the end point. So we are going to have 0, 3, and 4. So that's the reason why we drop the minus 1 out, because minus 1 is not in the domain. Right. So that's what you are going to get. So let's look for f of 0, f of 3, and f of 4, so that now we can conclude here. So what is our function? F of x is equal to x to the power 3, I think minus 3x squared minus 9x plus 5. So I love 0 when it is in form of like polynomial. This is going to be 0. So this is going to give us 5. Good. Then when you plug in 3 to the power 3 is like 27. 3 squared is 9. 9 times 3 is also 27. Then 3 times 9 is another 27 plus 5. So this and this will go. So when I subtract, I'm going to have minus 22. Good. Now let's look at 4. What is 4 to the power 3? So 4 to the power 3, I think it's supposed to be 64. Yeah, something like that. 64, because 4 times 4 is 16 times 4, yeah, 64. Yeah, can check the calculator to confirm it for me. And then 4 squared is 16, so 16 times 3 should give us 48. Then 4 times 9 is going to give us 36 plus 5. So let's add all of them. So 64 minus 48 minus 36, and then plus 5 is going to give us 64 minus 48 minus 36 plus 5 is going to give us minus 15. So we are going to have minus 15. So now we can conclude the absolute maximum and minimum. So the absolute maximum is 5, and the absolute minimum is minus 22. So this one at s is equal to 0, and this is at s is equal to 3. Wow. So this is kind of very simple. Like here, what you just need to do is make sure that you find the f prime, like when you are going, and then the most important thing here is the factorization, because if I know using calculators, the factorization is what is important here. And remember that here we want to know the one which is inside the interval, so we drop the one which is not inside the interval, and then we use our table to find the absolute maximum and then absolute minimum. One thing before I forget, anytime they don't specify absolute maximum and minimum, they will be like absolute extrema. When you hear absolute extrema, it means that the question is asking for absolute maximum, absolute minimum. Good. Now let's look at this one. A farmer has 52 years of fencing, and he wants to fence off a rectangular, so that's kind of like this one. So one side is like a river. So let's assume that this is my river here, right? Okay. And then we want to fence the rest. So the one that we are going to fence is the one with the black. So we are having something like this. So let's assume that this is x, and this is y, right? So when we fence, we are going to have 50, right? So it means that 50 is equal to x plus y, and this is the same as 52 2x plus y. So that's one equation formed, right? So we want to fence is like 52. So one of the fence is like with the river. So like this is where the river is. So this is my riverside. Good. So now, what are the dimensions of the field that will yield the largest area? So let's form the area. So we are saying that area is equal to x times y, right? So since we are saying that this is the area, then we need to make sure that this is in terms of only one variable. So we can make y the subject from here. So make y the subject, and y will be equal to 52 minus 2x. So let's just do the substitution. X times 52 minus 2x, and this is going to give us 52 minus 52x minus 2x squared. Yeah, this is what you're going to get. Now we can even find a domain here. Now domain is like picking this guy here and saying that is greater than 0. So like x 52 minus 2x is greater than 0. So x is greater than 0, and we can pick 52 minus 2x also greater than 0. This means that 52 is greater than 2x. Divide through by 2, and we are going to have x here. And when I divide 52 by 2, I'm going to have, I think, 26. Is that right? Yes. So it means that x is less than 26. So the domain here that we are going to work with, 0 less than 26. So here, when we are working, we need to work within our domain. We need to make sure that we are within our domain, right? So that will be the domain there. Now let's look at what we need to do. Now that we have the area, we want to find a dimension, right? we want to find the dimension that maximize the function. But make sure we find the domain. So the domain is what we find here for the objective function. And we need to also use the sign charts to justify the answer. So we'll do that. So we are done finding the domain for the objective function. So this is our objective function. So we use that one to find the domain. So we are saying that that's where the domain is supposed to be. Now, before we do the last one, let's look at the largest area. So what we need to do is we need to differentiate A. So we are going to have 52 minus 4x. So this is a linear function, so we can just pick 52 minus 4x and set it to 0. And we are going to have 4x is equal to 52. Divide both sides by x if 4, and I think x should be equal to 13. Yes, that's what we need to get, because this is like 2, 26, yeah, 13. So this is the x value that we are going to get. But the question is, we need to, use a sign chart to, justify our results. Like, we want to use it to justify, yes, this is what is going to give us the largest, or this is what is going to maximize the function. So what we can do is, let's just use a sign chart before we can go and look for the other value. That is why. So let's put my 13 here, and then I pick A prime and I put any value below 13. So I can pick something like 10 here, and then here I can pick something like, I just want to pick values that I can just easily multiply and then just go without using calculator, right? So when I plug in 10 here, what happens? 10 times this one is going to be 40, and then this is going to be positive. So this is going to be like greater than 0, and we are moving up here. Now I plug in 20 here, 20 times this is going to be 80, and 50 minus 80 absolutely is going to be what? Less than 0. So it's like kind of minus, and this is going to decrease. This is positive. So we can see that there will be at 13, we are going to have the largest area, like there will be a maximum in there. So this is a sign chart that is going to tell us that, okay, yes, this is showing that this is going to be at maximum. So we are done with the sign chart. Now let's find the dimensions. So now, since we know that s is equal to 13 is going to maximize the function, what will be the dimension? We know that y is equal to this. So we just pick this guy here and then find for y. So y is equal to 52 minus 2x. Now we know that x is 13, right? So 2 times 13, and this is going to be 52 minus 26, and this is going to give us 26 minus 52 should give us something like, I think, 26, so right, something like that. Yeah, 26. Yeah, so we are going to get 26. Yes, of course, that is supposed to be true. Is that true? Yes. So y should be 26. Right, so we can see that even from the domain, we saw that our 13 was also in the domain. So that's one thing that you also need to see whenever we are talking about domain, right? So I think this is what we need to do in this question too. So the idea is that when you practice, when you go to the exams, at least you should be able to, if a question is, when they give you a similar question like this, you should be able to find your way out. Like, and give you a similar like this, you should be able to find your way out. Yeah. Let's look at question 3. Question 3 is so fun, nice. Now, consider the function f of x where the area of differentiated regions is noted below. So region A is having area of A, so this is like 2. Region B is having area of 8, but we said anytime we have the area below the x-axis, it should be negative. So this one, I'm going to do it -8. So the area below is going to have -8. And then the C is going to be 6. Right. So now that we've done, let's go and look for the question that they are looking for. So first, this question is looking for integration from 1 to 5. So where's 1? 1 is here, 5 is here. So it means that we want to look at the area here. And it's already given, what is 8. So this is going to give us -8. So I need to just put my -8 here. Now where we are going to mark it. And then what we need to do is now we want to look at from 0 to 5. So remember, this is 0. This is where the 0 is. So we want to look at from 0 up to 5. But 0 up to 5 can be divided into 2. We can divide it into from 0 to 1 and then from 1 to 5. So we are looking at from 0 to 1 and 1 to 5. So it means that this integration can be written as integration from 0 to 1, right? Yeah, from 0 to 1 f of x dx plus from 1 to 5 f of x dx. And this is equal to, so from 0 to 1 is a, which is 2. So you are going to have 2 plus from 1 to 5 is b, which is minus 8. So we are going to have minus 8. So this will be 2 minus 8, and this is going to give us 6. So no, minus 6. Yeah. So this is going to give us minus 6. And then last one is we want to find the integration from 0 to 7. So we want to go up to this side. So what we want to do is now we want to look at the integration from 0 to 7. So we can divide this one into 3 parts. We can move here. We can move from here to here. And we can move from here to here. So from 0 to 1, from 0 to 1, from 1 to 5, 5 to 7. So we can write this one as 4 out. So I factor the 4 out. Then integration from 0 to 7 f of x dx, right? This can be written as 4 out. This can be written as from 0 to 1 f of x dx plus integration from 1 to 5. Or you can jump from, okay, let's just do it just 1. I just wanted to say you can just jump it, but let's just do it. So now because I wanted to start from 0 to 5 because we've done 0 to 5 already. Then we do 5 to 7, but let's just do everything again. Then f of x dx plus, now moving from 5 to 7, f of x dx. So this is what I'm going to get. So 4 times what is from 0 to 1, that one is here, what is from 0 to 1 is 2. So we are going to have 2. From 1 to 5 is minus 8. So minus 8 plus from 5 to 7 is 6. So 6. So this is going to give us 4. This plus this is going to give us 8. So minus this is going to be 0. And everything goes to 0. So we are going to have 0. So this is very nice, like kind of very, very simple. Now, when you get some question like this, you should be able to get everything right. Do you get it? Yeah. So basically, that's how it is. And then mostly one thing that I want to point out is like when you are marking to like kind of, for me, like the one I'm marking, if this one like this, you get it wrong and like kind of you are doing something like this, I try to give you some marks. So it's always good for you to do something like this, even if let's assume that, and always solve. Like even when you solve, don't claim the solution. But let's assume that here is minus 6 and mistakenly you wrote 6 and there's no solution here. I will not even know whether you are just doing that thing right. So I'll just take you wrong because like you are just putting the minus 6 here, even though we just mark this. But this one too is going to show with your solution that okay, she had minus 6 here, mistakenly writing this. So then just mark it out. All right. So that is for question 3. Let's look at question 4. Using the fundamental theorem of calculus, we need to evaluate this. Simplify your final results and put it in the box. So we simplify, put our final answer here. When you solve and you are done, don't claim the solution. Just leave the solution there, okay? So that if even your simplification, you get it wrong, we can look at the solution and then just give you something. For me, for example. So what we need to do is now, let's try and integrate this, right? So 6x squared, or like this is 1. So we know that plus 1 divided by 1 plus 1, right? Then plus, when I integrate a constant, I multiply by the what we are integrating with respect to. So I'm getting 2x from 0 to 5, right? So what I'm going to get 6x squared divided by 2 plus 2x, still from 0 to 5. And then this is 3x squared plus 2x from 0 to 5. So let's just plug 5 in. So I'm going to have 5 squared minus 2 times 5. I put it into what? Parentheses minus. Now when I plug in 0 here, 0, 0 here will be 0. So like 0 minus 0. And then 5 squared is like 25. 25 times 3 is going to give us like 75 minus, 2 times, 5 is 10. And this should be giving us like, this is minus 0. And this is supposed to be giving us 65. So this should be giving us 65. Right. So that's what we need to get at the end of the day. So like kind of, let's assume that you are doing the thing, you've gotten here, you didn't do the substitution very well. And I gotten this one wrong. If you clean your solution and you write, let's say here, maybe this some manipulation, this one was like 0, and then you had 75. I will not see that you were even doing the right thing to mark you. So always leave your solution so that we can just check, and then if you deserve some marks, we can just give it to you. Let's look at question 5. Now, question 5, we just want to use integration by substitution, like use substitution. So as I said, always if we want to do substitution, you look at the terms here. The one with the highest degree is what you are going to pick it to be what? U. So we can see that the one in the bracket here is the one which is having the highest degree. Don't just pick U to be x squared. No. Pick U to be equal to everything here in the bracket. So here, I'm going to let U to be equal to x squared plus 9. So look at something here. If I do that, this is what I'm going to do. I write my integration as x squared plus 9, or I factor the 4 out, then x dx is equal to. So if you look at when I'm doing substitution, anytime I'm doing substitution and I pick the one with the highest degree, I try and move the one with the lowest degree to dx so that I can show you this. So I bring the 4 out, I move this one close to the dx so that now when I'm doing this, this is kind of, I'm going to have something like this. Look at it. I'm going to have something like 4 integral. Now the one in the bracket here, oops, this is to the 7. So the one in the bracket here is u now. So I have in u this. So what I now need to figure out is I need to figure out x dx, and I can get that x dx inside here. So when you do the substitution, you can try to rewrite the function again, and then it will tell you what you need. So I factor the 4 out, I have this. I know that this is equal to u, so this is what I have now. I need to go and figure out x dx. So for us to do that, I need to differentiate my u. U over the x is equal to, when I differentiate this, I'm going to have 2x. Let me just bring this guy down small. So now make the du the subject. So du will be equal to 2x dx. We need x dx, not 2x dx. So I need to divide through by 2. So I'm going to have du over 2 is equal to x dx. So now in place of x dx, which is here, I'm going to replace it by du over 2. So one thing about integration by substitution or u substitution is that anytime you are done changing the variable from x to u, you shouldn't have x in it. Good. So you see that now my new equation here does not involve x, like the original function. So that is what we need to do. Now 2 can cancel itself, 1 cancel here 2. So we are going to have 2 integral u7 du. So what can we do? Let's do the integration. 2u, like 7 plus 1 divided by 7 plus 1. Now don't forget this is indefinite, so plus c. So this is going to give us 2u8 divided by 8 plus c. Now we are not done. Now remember, our integration is in terms of x. So it means that our final answer too should be in terms of x, not u. So what we need to do is Our final results, or the final thing that we need to do, is now look for u. What is u? We said u is equal to x squared plus 9, and we come and plug it in there. So our final solution is what I'm going to write here. So our final solution will be equal to, I can even divide this and this. So let me just simplify it here. So this is going to be u to the power 8 divided by 4, and then plus c. So when I plug in the u, which is x squared plus 9 all to the power 8. So I'm just doing substitution here for the u, which is equal to this, divided by 4 plus c. So this is what I'm going to get at the end of the day. But you see that it's kind of very nice. Like when you are doing it, it's kind of something very nice. But I can use just not good approach, like kind of, let's assume that this is objectives and I'm just doing it. I can just use some smart approach to do this. What am I going to do? The basic integration here is equal to this. Look at what I'm going to do. I'm going to use the power rule, so I will maintain x squared plus 9 all to the power 8, like 7 plus 1 divided by 7 plus 1. So you see what I'm doing? Like I have this one here, I'm adding plus 1, but the function is times 4x. Then I would divide it by the derivative of what is inside the bracket. So the derivative of what's inside the bracket is actually 2x. So what happens? I'm doing magic. So x will cancel x, right? So what is going to be left? It's going to be left with 4x squared plus 9, 8. Down here will be 8 times 2. Now what happens? So 2 times 8 is going to give us 16. And when I cancel, this one is going to be 4, and this one is going to be 1. I add my plus c. That's what is here. Can you see that? So the idea is that when you master the integration, you can use eye inspection, knowing where you are going. But this one, the question is saying that we should use the u substitution. So anything that you are going to do aside the u substitution, you are getting everything wrong, because this is like something that they ask you to do. It's kind of, if a question is asking you to use the limit definition and you just differentiated it, you get 0. Right. So that's what you are going to get. Let's look at question 6. Find the following indefinite integrals. So what can we do? This is kind of very nice. So this is going to give us something like 3x4 plus 1. So we add plus 1 to all of them, and then we divide it by 4 plus 1. Right? Same thing to the next one, like we are going to have plus 2x to the power 3 plus 1 divided by then 3 plus 1. So I'm just doing the plus 1 with red so that you will notice what I'm doing. So minus 4x, remember x is to the power 1. So I'm going to have 1 plus 1 divided by 1 plus 1. That's what's on the top there. Then plus, whenever I'm integrating a constant, I multiply by x, the one I'm integrating with respect to. So I'm going to have 9x. This is indefinite, so I add plus c. Then the thing that I just need to do is I just need to simplify. So this is going to be 3x to the power 5 divided by 5 plus 2x to the power 4 divided by 4 plus minus, so this is going to be minus 4x squared divided by 2 plus 9x plus this. So you see that after I'm doing it, you see that this one is the same as this one is the same as this one is the same as this. Like anytime you have the powers. Then if I want to do the final simplification, I'm going to have my final answer to be 3x to the power 5 divided by 5 plus x to the power 4 divided by 2 minus 2x squared plus 9x plus c. C is important. You need to add plus c because this is indefinite. So you need to add plus c. And let's look at this. So you look at this one. When I started, I just started doing the integration because this is like all of them are already simplified. It's in a polynomial function form, like it's a polynomial function. So I just started. But this one is not a polynomial function. We have, rational function. We have radical function. So we need to just simplify before we do the integration. So this is the same as e to the power 2x plus 4. Then square root of x is the same as x to the power 1 over 2. Then minus 3 times. Now remember, this is 1, so I'm not going to bring it up. So I'll write it 3 times 1 over x dx. So this is what I'm going to do. So now I'm done with the simplification. So now let's do the integration. So when I'm differentiating e to the power 2, I'll maintain e to the power 2 and then divide it by the derivative of what is on the top here. So let's divide by the derivative. So let me just write it dx over this so that you know what I'm doing. So I'm just differentiating what is on the top, like 2x, right? Then plus, now as we know from this one will be 4, 1 over 2 plus 1 divided by 1 over 2 plus 1. And then minus 3. Then when I'm integrating 1 over x, I get the natural log of what? X. So I put the absolute on it because we don't have the interval, so I don't know whether it's positive or negative. Then since this one is indefinite, I'll add plus c. Then I'll go through the simplification. This is u2. When I differentiate 2x, I get 2 plus, this is going to be 4x to the power half plus 1 is 3 on 2 divided by 3 on 2 minus 3 natural log of x plus c. Final simplification before we go. This one is like 4 divided by 3 on 2. So 4 times 2 on 3, and this is 8 on 3. So I'm going to have e2x over 2 plus 8 on 3, 3 on 2 minus 3 ln of x plus c. Wow. So this is what I'm going to get for this particular function that we have here, which is very nice, like kind of very nice for us to just look at what we are just doing. All right. So this is question 6. Let's look at question 7. So question 7, this is what we call the integration by part. And when I start my integration video, basically I will do like something like, oh God, like proving that when you use the product rule from differentiation, we are going to get the integration function here. But now we just need to use it. Now, the question is, if we use integration by parts on this is what we are talking about, on this integral with u is equal to x, then what is your div equal to? So this is very simple. Let me write something here so that we can compare it. So I'll just write the integration here, and then I have my x e3x. Okay, let me just write it boldly here, down here. So we have the first part of the integration by part, which is u div. And then our integration that we are working with is x 3x dx. So I'll show you something. So basically we can see that one, we have integration, so it is gone, right? So integration, so you see what happened. Integration is gone. Then the question is saying that we are choosing u to be equal to x. So now, since u is equal to x, then it means that u is equal to this x here. So what will be left? Everything left is the v. So it means that our div is equal to e to the power 3x dx. So that's one thing that you need to know. So when you are looking at it, when I pick u to be this, then everything left is for this guy here. So you see the way I covered it, and then I was able to figure it out. Good. So that will be my div. Good. Now, with the choice of u and div in part A, what is du and what is v equal to? So we want to find du. We can get du from this, and we can get v from that. So let's pick our function. We have u to be equal to x. So if we want to talk about du, then it means that we need to differentiate this with respect to x. And this is going to give us 1. And this implies that du is equal to dx. So we are done. So now we know that du is the same as dx. Now we want to find vin. How can we get vin? We can get vin from here. So what can we do? I think let me just shape this one small, bring this one here, and bring this one to up here. So like this is implied. Then the vin is equal to e to the power 3 dx. Now how do we get vin? For us to get vin, it means that the d should go away. For us to get the d out, we need to find the integration. So the vin is equal to integration with what? And the fun thing is d will cancel the integration. So it means that this is going to be left with vin, which will be equal to, then now we need to integrate this. So how do you integrate this? Maintain e to the power 3x and divide it by the derivative of what is on the top, which is 3x, and this is going to give us 3. Don't add plus c, right? Because this is integration by part. So this is our du, and this is our what? Vin. Now let's look at c. Now with this c here is now we need to now solve this itself. So now we know that integration x e to the power 3x dx now is equal to, using the integration by part formula, which is here, but because we said this one was equal to what is here, so let's use the formula here. So that the formula is u vin minus integration vin du. So let's do it. What is u? We saw that u is equal to x from the question here. So u is x, so I write my x times, what is vin? Okay, this is my vin. So you see what we are doing? We use a to do b, we use b and a, we are using it to do c. So if you get any of them wrong, it means that everything is going to be wrong. Good. So what is vin? Vin is this. So I multiply by e to the power 3x divided by 3 minus integration. What is vin? Okay, we have the vin there, divided by 3. And what is du? Du is the same as dx, so we are going to have dx. Good. So now let's simplify. This is 3e to the power 3x over 3 minus, here I can factor 1 over 3 out, and then I need to integrate this function right here. Now what is happening here? There is something that is happening here that we need to see. Now from here we can see that now we need to finally integrate this. Now I think we've done even this, which was giving us this, and we had this. So finally we are going to have x e to the power 3x divided by 3 minus 1 over 3. Then when I integrate this, maintain the function and divide it by 3 plus c. Yes, so this is what you're going to get. And then if you want to do the final simplification, I can put the final simplification here. So finally, we are going to have it to be x e to the power 3 divided by 3 minus 3 times 3 is going to give us 9. So e to the power 3 over 9 plus c. So this will be the final results for the integration. This is what you are going to get for the integration. So integration by part, as I did it, try and pick your u, but this one, they did what? They picked the u for us, and then we need to figure out the vin, which we did the cover up, comparing this to this. So anytime you want to find your u and the vin, you need to compare this to the first term here. And when you are doing the final integration, then your final integration here now supposed to be equal to what is here, using your vin and your u and your du. Right. So this is 7. Let's look at the last question and then we are done. So the last question here is, now we have this question here and they've already drawn the graph for us. So it kind of, things are not all that difficult for us. So this point basically says y and x is intercepting. This point here is 0, 0. So what we need to do is we need to look at this point here. But one thing that you need to notice from here is that this line here is when y is equal to minus 6x. And this line here is when y is equal to 2x squared. So that's what you have given it to us. So basically, for us to know the point here, we need to solve this and this simultaneously because this is intersecting, right? So if y is equal to this and y is also equal to this, then 2x squared is the same as what? Minus 6x. So let's do that. So that's the first thing that we need to do. So this y is equal to 2x squared, y is equal to minus 6x. So it means that 2x squared is equal to minus 6x. Nice. So what can we do? We can move this guy here and get plus 6x is equal to 0. And what can we do? We can factor 2x out. And what will be left? It will be left with x plus 6, no, x plus 3. And this is equal to 0. So we can see that when I pick 2x is equal to 0, x should be equal to 0. Right? For this to be 0, when x is 0, everything will be 0. Then it's also not difficult to see that x plus 3 is equal to 0 and x should be equal to minus 3. So the point that we are having here is when x is equal to 0 and when x is equal to minus 3. So now let's try and figure out the point. So when x is 0, what happens? What will be y? Put 0 here. This one will be 0. Put 0 here. This one too will be 0. So it means that y will be 0. So we have one point to be 0, 0. Then when x is equal to negative 3, put negative 3 here. Negative 3 squared is positive 9. 9 times 2 is 18. Negative 6 times negative 3 is also 18. So we are going to have minus 3 and 18. So the point that we can see is the 0, 0 that we have here is the one that is showing here, the one that I just saw it from there. And the point here, minus 3 and 18, will be this point. Minus 3 and 18 will be this point. Minus 3 and 18. Minus 3 and 18 right here. But the idea is that now we want to find the area under the curve. So now when we want to find the area under the curve, we are trying to look at this area here. So we need to get the x value. So now we find out that x value here is minus 3 and then the x value here is 0 as we saw it from here. So x is 0, x is minus 3. Right. So let's try and do the integration. So we are going to have integration from minus 3 to 0. And then now we will see that this is on the top. So this one should come first, followed by the down. So this one is going to be minus 6x minus 2x squared. So if you want to find area between two curves, right, what you need to do is pick the first function, pick the graph which is above. So you can see that this is the one above, right? This one here is the one above, minus the function below. So the function above is minus 6 minus the function below, what is 2x squared. So this is what we have here. So now we do the integration. So now let's go to the integration. This is going to give us minus 6x squared divided by 2 and then minus 2x to the power 3 divided by 3 from minus 3 to 0. So that's what you're going to get. And plug in 0 and everything will be 0. So like 0 here will be 0 minus now, let's even simplify. Let's do that. So here we're going to be like minus 3x squared minus 2 over 3x to the power 3. And from minus 3 to 0. So let me just clean up solution and then we are done. So this is the last question that we are doing. Thank you so much for staying here with me. So now here is going to give us, when I plug in 0, everything will go to 0, minus, I open bracket and then I put negative 3 in. So minus 3 squared minus 2 over 3 minus 3 to the power 3. So this is going to be minus 3 squared is 9. 9 times minus, this one is going to give minus 27 minus 2 over 3. This is going to be 27 also as well. So this is going to be like minus 27. Right. So let's put the final results here. this is minus open bracket, so equal to minus 27 minus, now look at this, 3 goes to itself 1 and goes to 27, how many? 9, right? So now minus 2 times minus 9 is going to give us plus 18. So this is going to be plus 18. And when I do the subtraction, I think this one's supposed to give us minus 9. I think so. Yes. So this, oh no, not minus 9. Yeah. We have minus in front. So minus 9. And then our final result should be a big 9. Big one. So like this is my final question. So my final answer is very big, big one, right? Good. So thank you so much for joining us here. And I think the next video I'll do a discussion sheet that we are going to have this week. I'll just also do it and come and put it there. So if you watch all these 4 videos, like you should be able to prepare yourself to write the exams. I wish you all the best in your exams, and I know you've been impressing me, and I know you are going to do that. Yeah. Thank you so much, and see you in the next video.